Welcome back everyone to this lecture on constraints. Constraints is the last thing we're going to learn about theory-wise before we actually head into using SQL syntax to create tables. Constraints are the rules enforced on data columns on a table. They can also be used to constrain everything in a table, and we'll talk about that in just a second. So constraints are used to prevent invalid data from being entered into the database. This ensures the accuracy and reliability of the data in the database. Constraints can generally be divided into two main categories. There are constraints on a column, which constrains the data in a single column to adhere to certain conditions, and then there are table constraints, which are applied to the entire table rather to just an individual column. So let's talk about some of the most common constraints used. The first one is not null. So the not null constraint is pretty self-explanatory. It's essentially telling you that a column cannot have a null value. Essentially, if you're going to enter data into this row that includes this column, it has to actually include a value for this column. So for example, if you're creating a table that happens to take in customer information and you always need an email from them, then you can say that the email column has a not null constraint, essentially saying that you are required to provide an email for this customer, otherwise it's an invalid row and it won't let you add it to the table. Then another constraint that's really common is the unique constraint. This ensures that all values in a column are different. So a unique constraint could be used as something like a customer ID column because you want each customer ID to be unique. You wouldn't want to use a unique constraint on something like a first name column because people can definitely have the same first name. So unique, again, ensures all values in a column are distinct or different. Then there are primary key and foreign key constraints. We already learned about primary key and foreign key, but the way you actually define them when you're constructing your own table is you set them up as a constraint. So the primary key uniquely identifies each row or record in a database table, and a foreign key constrains data based on columns in other tables. So when you're setting up a foreign key, you'll actually also set up a relationship to another table you created. And there's two more column constraints I want to mention here. And check and exclusion are these constraints. They're a little more complicated, so I'm just going to give you the official definition for now, and they're going to make more sense in the next series of lectures when we actually programmatically use them. So keep that in mind. Don't worry about fully understanding these constraints because it depends a lot on the additional conditions you apply with them. So the check constraint ensures that all values in a column satisfy just some certain general condition. So you actually check against some sort of condition, such as has to be less than 20 or something like that. The exclusion constraint ensures that if any two rows are compared on the specified column or expression using the specified operator that you include with the inclusion constraint, that not all of these comparisons will return true. So don't worry too much right now about understanding check and exclusion because they actually depend a lot more on the additional conditional constraints you provide. Okay, so those are all available column constraints that you apply on an individual column. And you can also apply constraints across an entire table. And some of these table constraints just also use the same keyword that are used on the column constraints. So on a table, you can also have an additional check, and in parentheses, you pass in some sort of condition. So you check a condition when inserting or updating data across the entire table. You can also provide a references constraint, which is to constrain the values stored in the column that must exist in a column in another table. So it has to reference another column in another table. There's a unique column list constraint. So you pass in a list of columns into unique, so it applies across multiple columns across the table. And it forces the values stored in these columns listed inside the parentheses to be unique. So instead of just having something be unique within a column, it's going to have to be unique within multiple columns. So that's why this is known as a table constraint, because it's expanding it beyond just a single column. You can also do primary key on multiple columns, so it allows you to define the primary key that consists of multiple columns. Typically, when you're starting off, there's usually just one primary key column per table, but you can have multiple primary key columns per table. And if you wanted to set that up, you could do it using a table constraint, which is passing in multiple columns into this column list along with primary key. And that's pretty much it. So we understand a couple of core concepts in theory. We understand data types, how to choose data types. We understand primary keys and foreign keys. And then finally, we understand the options for constraints. These constraint options are going to make a lot more sense when we actually program them out in the very next lecture. So don't worry too much about fully understanding them right now. Basically, I just wanted to introduce the keywords to you. That way they didn't seem to come out of nowhere in the next lecture. So with all this under our belt for theory, we're ready to begin using SQL syntax to create tables. So let's go ahead and do that, and I'll see you at the next lecture.